What if you have a value with a certain unit attached to it, and you want to change the unit that you have that you're using in your value? If you're going to do that, what you're going to do is perform something we call dimensional analysis. Now, this sounds intense. It sounds like something out of a Star Trek episode, but it's really not as intense as it seems at first glance. So if we consider the following here, you're baking some cookies at home. I did this the other day. And the recipe calls for 1 tablespoon of cinnamon, but you have dirtied all of your tablespoons already. At some point, you've been doing a lot of cooking, and you've already used up all your tablespoon measures. However, you do have a teaspoon that is still clean. You have a teaspoon measure, and so what you do is, because you remember that 1 tablespoon is the same as 3 teaspoons, you grab your teaspoon measure, you add 3 scoops, 3 of those teaspoons into the mixture, and you go about making your cookies. What you just did there is dimensional analysis. It's the process of taking a number with a unit attached to it and realizing that you can describe that same physical thing, whatever it is that you're interested in this case it was the tablespoon of cinnamon, you can use a different unit to describe that real life thing. So instead of 1 tablespoon of cinnamon, we used 3 teaspoons of cinnamon. Now these are the same exact physical objects. It's the same volume of cinnamon either way. One just has 1 unit attached to it, and the other has a different unit attached to it. So dimensional analysis is taking one value and using unit conversions to find the same value with a different unit. Now this one was fairly simple, and we kind of just did it in our head without even thinking about it too much. But as we'll see in just a minute, there are more complicated conversions that we'll need to do sometimes, and so we're going to come up with a method for doing these. But before we do that, just to kind of preface doing this mathematically, we need to think about what we're actually doing when we're doing a dimensional analysis problem like this. We're going to think about mathematically how we're going to describe this process. And the key to this overall thing is realizing that when we take something and multiply it by 1, we don't actually change its value. So if I were to take the number 12 and multiply it by 1, it's still 12. I don't change anything by multiplying by 1. The same is true for dividing by 1 as well. Multiply by 1, divide by 1, raise to the 1, it's still going to be the same value, no matter what we do there. If we're multiplying it by 1, it's still going to end up being the same. So with that as our starting point here, remember we said just a minute ago, when we were looking at our example with the cookies, that 3 teaspoons is the same as 1 tablespoon. In the same way that 12 inches is the same as 1 foot. Because they are describing the same physical thing, we can say that one is equal to the other. So 12 inches is equal to 1 foot. So we're just now mathematically saying what we were saying before. We're actually putting it into an equation. So 12 inches is equal to 1 foot. 3 teaspoons is equal to 1 tablespoon. So if we were going to go back to what we did before, we can use that relationship that we had before. 3 teaspoons is the same as 1 tablespoon. And if we multiply the 1 tablespoon that we started off with, so this is what we were looking for. We wanted 1 tablespoon of cinnamon, but we realized we don't have a tablespoon. How many teaspoons would that be? Take that starting amount that we're trying to change, multiply it by this fraction or ratio, whatever you want to call it. What we get out the other side is 3 teaspoons times 1 tablespoon over 1 tablespoon. Because both of these have the 1 tablespoon there, if you remember your algebra, if you have the same thing on top and bottom of a fraction, they cancel each other out. So those tablespoons go away, leaving us with 1 teaspoon. Now notice here, this is equal to 1. This ratio that we made from the equality that we had on the previous slide here, because remember back here, we said that 3 teaspoons is equal to 1 tablespoon. We took this equality and we put the two sides into a fraction here. And we arranged it so that the thing we wanted to disappear would cancel out with the starting unit that we had, which was a tablespoon. And so we flipped this way so that we had tablespoons on the bottom, tablespoons on the top, and those canceled out in our equation here. And this is what we're going to be doing with these dimensional analysis problems. We are going to be multiplying a value by 1 in order to change the unit, but not change the actual value itself. So the number is going to change. As you can see here, we started with 1 tablespoon, and we end up with 3 teaspoons. But the actual physical value has not changed because 1 tablespoon is equal to 3 teaspoons. We're still describing the same thing. We've just changed the way that we are talking about it. We've changed the way that we're describing it. So these fractions that we're going to use here, we're going to call these conversion factors. And they're always going to be equal to 1. It is always just some equality. We have one thing is equal to something else, and we're just going to take the two sides of that equality and stick them into a fraction and arrange them whichever way we need to in order to get the units to work out correctly. So these conversion factors, like I said, always are going to be equal to 1, but there are going to be many, many of these that we're going to see throughout the class. There are practically infinite numbers of conversion factors, but we're not going to use an infinite number of them. But we will use quite a few because they're very, very handy. They're very, very useful for science in general, especially in chemistry though. So conversion factor is any fraction that converts a quantity expressed in one set of units into an equivalent value expressed in another set of units. So 10 millimeters is the same distance as 1 centimeter. They are physically the same thing, and so again we can take this equality and we can turn it into a conversion factor with either centimeters on the bottom or centimeters on top. So either one of these is a perfectly acceptable conversion factor, and we would decide which one of these to use just based on what units we were trying to cancel out and what units we wanted to keep. It just will depend on the situation. Alright, so let's look at a step-by-step process here for how we're going to solve these kinds of problems. So, step 1, we're trying to do a dimensional analysis problem, is we're going to write the value that is going to be changed as a fraction. Even if it is just one thing, so there's not a second unit, there's nothing in the denominator, we're still just going to put a 1 there just for the sake of consistency. We want it to look as consistent as possible as we go from one problem to the next. So we have, in this case, 6 feet that we want to change to inches. So then the second step is we are going to multiply by the conversion factors needed to change the value to our desired unit. So we would need to figure out what is the relationship between our starting unit, feet, and our desired unit, which is inches in this case. And as I'm sure you know, the relationship between those two is that there are 12 inches in 1 foot. Now keep in mind this isn't the only way that you could write this out. There's any number of ways that you could put this in here, but the ratio is going to stay the same. So if you just felt like being different, you didn't want to do 1 foot for every 12 inches, you said, I want to do for every 2 feet, there's 24 inches. Well, that's true too, and that would still work. If you plug those numbers in here, you're going to get the exact same value. Just as long as the two sides are equal to each other, we actually don't care what the numbers are. If you wanted to work out how many feet there are in 1 inch, you can use that too. But 12 inches in 1 foot is the most common way of representing that. So step 3, we're going to cancel the units. So in this case, the feet are going to cancel out, leaving us with just inches. And so then finally, we do the math. So we have 6 feet times, and actually the feet are gone at this point, so it's 6 times 12 gives us 72, and the only unit that is left is inches. So we have 72 inches. Now, you might be thinking, well, that was a really simple question. I could have done that in my head. I already knew that 6 feet was 72 inches. Why do we have to have this 4-step process for simple questions like this? The reason is, they're not all going to be this simple. So, let's look at some more complicated ones. So, we have 1.6 times 10 to the third meters, and we want to convert that to miles. Now, I realize here we actually haven't seen scientific notation yet, so I'm going to work through this one with you first, and then we'll look at more scientific notation in the coming slides. But the process is going to be the same. So we're going to start here with 1.6 times 10 to the third meters. We're going to write it as a fraction. I already have all the conversion factors that we're going to need listed over here on the right. So to get from meters to miles, we're going to need 2 different conversion factors. Now, you could find the one conversion factor to take you directly from meters to miles, but we can use more than one. That's perfectly fine, because we can multiply by 1 as many times as we want, and we still won't change the value. So the first conversion factor I'm going to use is this one right here. This tells me that for every 1 meter, that is the same as having 3.28 feet. Now notice here I put meters on the bottom. That's because I want it to cancel out the meters that's on the top here. So then the second conversion factor, there are 5,280 feet in every 1 mile. And if we do that math, if I remember correctly, it comes out to just under a mile. But let me double check that on my calculator. Yes, so that is 0.994. And if we check our units, the meters have canceled, feet have canceled, and that leaves us with just miles as our unit. Okay. There we go. So then the second one here is a little bit different. So in this second example, we have more than 1 unit. We have 65 miles per hour, and we want to convert that to kilometers per minute. Anytime we have a unit per some other unit, so in this case it's mile per hour, whatever unit comes after the per, that goes down in the denominator. It's saying we go 65 miles for every 1 hour of time. This is a very common mistake by students, is trying to put both the miles and the hours up in the numerator. It's going to get you all messed up in terms of the math here. So anytime you have something per something, that first unit goes in the numerator, second unit goes in the denominator. So we want to convert this to kilometers per minute. So we have 2 different units that are changing, so we are going to need 2 different conversion factors. And once again, I've given you the ones that you need here. One of them you already know, which is there are 60 minutes in every 1 hour. Now we're going to want to put the 1 hour on the top because the 1 hour is on the bottom here. And we want those to go away and leave us with minutes. So we're going to put 60 minutes here on the bottom. For the second conversion factor, we want the miles on the bottom and 1.61 kilometers on the top. because again we want the miles to cancel out here. And it does not matter that there is a conversion factor in the middle here between these. It's all multiplication and division, so the order of operations here is not going to mess us up. So we have the hours here canceling out, miles cancel out, and we're left with kilometers per minute, which is good because that's what we want. And if we do that math, let's see, 65 divided by 60 times 1.61, that gives us 1.74 kilometers per minute. Now, for those of you that it's been a little while since you had algebra, when we're doing the math here, the simplest way to do that is just to take everything in the numerator, multiply those together, and then divide by everything in the denominator. So it would be 65 times 1.61 divided by 60. Multiply everything together on the top, divide by everything on the bottom. Okay. Why don't you all pause the video here, and the reason I'm scraping this out, by the way, is because I don't think that example number is correct. I think these are from an older book, so I apologize for that. But there are other examples you could do in the book if you're interested in doing that. But why don't you pause the video and see if you can work out these two examples. So go ahead and pause the video now, and then come back when you think you've worked them out. Alright, hope you tried to figure that out on your own. We're going to do the first one here, which is converting 35 years to minutes. So if there are any of you out there that are exactly 35 years old, you just turned 35 years old this very minute, we're going to figure out how old you are in minutes. So, there's a few different ways we can do this. You could go to Google and ask it how many minutes there are in a year, and it would tell you. We're going to do it a slightly different way, though, because most people don't know how many excuse me, minutes there are in a year, but you do know how many days there are in a year. And you know how many hours there are in a day, and you know how many minutes there are in an hour. And so we can work it out that way. So, first thing we want to do here is for every 1 year, there are 365.25 days. Now, if you're wondering, why are there 0.25 days in there? Leap year. If you're 35 years old, you've lived through a few of those. And we don't want to leave out your leap days. There's a whole bunch of minutes in those. So we're going to go ahead and include the leap day in there. Now, if you did this and you forgot the leap day, don't feel bad. I'm just being extra precise here. Alright, so if we know how many, we've now converted out of years into days. We also know that for every 1 day, there are 24 hours. And we know that for every hour, there is 60 minutes. So 1 hour is equal to 60 minutes. And so again, our days here have canceled, and our hours have canceled. So, if you are exactly 35 years old, then you have lived. If we do all that math there, so just multiplying all those numerators together, the only thing in the denominator is 1, so we don't really have to do anything there. You are, let's see, that would be... let's see, we'll cut it off here. Well, actually, no, let's not cut it off there. Write that out again, because we want to know exactly. And again, we're assuming that you turn 35 this minute. So if you turn 35 this minute, then you are 18,408,600 minutes old. Or, if you don't want to have all those digits in there, 18.49 times 10 to the 6. minutes. A lot of minutes. That's a lot of minutes. Almost 18.5 million minutes in 35 years of life. Okay, what about converting 5.7 liters to cubic inches? Now, if you tried to work this one out on your own, actually, before I move on to this one, real quickly on this one. If, as you were trying to work through this, you tried to go from years to months, you probably realized that doesn't work. You can't say there are 12 months in a year, because then where do you go from there? There's no even way of converting out of months, because every month has a different number of days. And so you really do have to go straight to days from years, because the months don't really work out. All right, so back to the liters to cubic inches here. You probably realized pretty quickly that you needed to figure out some conversion to go from the metric system into the English system. So for our purposes, 2.54 centimeters, ran out of space there, 2.54 centimeters is the same as 1 inch. That's going to be our key here, but we also need to realize that 1 milliliter is the same as 1 centimeter cubed. So you would have had to work that out as well. So if we go ahead and solve this, we have 5.70 liters. We need to convert this to centimeters cubed so that we can get to the inches here, because that's our connection there. So for every 1 liter, there are 1,000 milliliters, and we'll talk more about those prefixes, I believe, in the next video. But for now, just know that for every 1 liter, there are 1,000 milliliters. For every 1 milliliter, there is 1 centimeter cubed. And we know that there are 2.54 centimeters in every 1 inch. So our liters cancel, milliliters cancel. Do our centimeters cancel? They don't, actually. They do not cancel, because this is centimeters cubed, and this is just centimeters. So even though it is the same, there's more of them here. This centimeters cubed is actually centimeters times centimeters times centimeters. That is what centimeters cubed is. There's actually 3 units of centimeters there. And so to get the correct value here, we actually need to cube this conversion factor. So this way we'll have inches cubed and centimeters cubed. Now, alternatively, you could just put 3 of these conversion factors, so you could have this same thing just copied 2 more times, but this is much more efficient to just go ahead and cube the whole thing there. All right, so if we do the math here, it's going to be 5.7 times 1,000 divided by 2.54 raised to the 3rd. Because again, we've cubed this. And so what this is going to be is 347.8 inches cubed. Because again, if we check our units here, those centimeters cubed have now canceled out, and we're left with inches cubed. All right, I think we'll call it there for this one, and the next one we'll pick up with temperature and converting from one temperature scale to another, and just generally talking about the temperature scales and how they're used. So I'll see you in the next video.